with the help of these applications, I can control whatever I need to do with that particular device. Am I clear till here? Are you
Yes,
with
sir.
me?
Yes, sir. Got it clearly.
Right, right. So how the IoT connectivity is done in electric vehicle? So there is, first of all, there is some charging station. Charging station is having some power grid connection. Charging station is connected with power grids, and there are some ports like charging start or stop button, again the energy metering and troubleshooting if there are some some missing things, or there are some issues inside that device, so there will be troubleshooting. So this charging station will connect with the management platform, like cloud-based services or whatsoever, where the data will be stored, analyzed. It will be monitored remotely. Again, the self balancing will be done if the charging station is having four or five charging points, so that there should be properly load balance, so that there won't be any power issues, right? Again, the firmware upgrades, if there are some software upgrades and all that, all those things. Again, the alerts and notification will be given to the management platform, so that there will be some monitoring authorities, or there will be some monitoring device which will read those notifications, which will create the alerts if anything goes wrong, right? And the other thing will be mobile application. So mobile application, what will the mobile application do? It will authenticate the user, so that just the authentic user, just the appropriate users, whichever user is having that whole ID and password. So just he can communicate with that charging station. He can authenticate. He can turn on the charging station, so that there won't be any frauds, or there won't be any misuse of that energy, right? Again, the charging network navigation, wherever so in my mobile phone, I can while traveling from one place to another, so in my mobile phone I can see that where are the charging stations, how the charging station network is done, so that I can navigate from at current location to that charging location, whichever will be nearby to me. Again, what that mobile application will tell me, if there is some reservation done, so that if I know that from one place to another, I'll going to require 1 hour, and after that 1 hour I'll need to charge my electric vehicle. So I'll early time only I'll reserve my that timing slot, so that there won't be any waiting for me to there won't be any waiting should be done for me. It will be easy for me, just go there, just plug in the charger, that there won't be any line, or there won't be any I don't it won't be I won't be needed to stand in the queue, or to keep my vehicle in the queue to get charged, right? Again, charging start and stop, schedule the chargings, and billing and payment. All these things I can do with the help of mobile app. So this is an virtual map of an IoT. So there are EV charging points. Again, this EV charging points, the camera and digital signage. With the help of digital signage, I can log in into my account. I can tell that monitoring device that how much time I am going to need to charge my vehicles, or whatsoever, how much charging is remaining, or what is the balance of my account, whatever the money payment should be done, or the billing should be done. It will be done on digital signage. Again, IP camera, there will be some cameras located there, so I can watch my vehicle while it is getting charged. If any third person is not trying to do anything wrong with my car, or not going to me do some mischief with my cars, right? So I can see that, I can monitor those things with the help of live camera devices. Again, the charging points will be, obviously I'll connect my electric vehicle to that charging point. So all these things will be connected with an internet with the help of GPS module. Again, the GPS module will be there so that I can see the current location of my electric vehicle and current location, the actual location of EV charging point. So I can see that whichever charging point is nearby me. Right. So this will be connected with the internet over the 5G or 4G network or the radius Wi-Fi, right? And all those things will be monitored, or all those things will be like all those data will be collected at cloud IoT platform, and that cloud IoT platform will analyze that data, store that data, and it will again forward that data to the monitor center. Again, that data will be given at the web application or our mobile phone app. So in this way, whole process goes on. Right. So how this IoT work? Like just for an example, if this is a charging station, I need to travel to the charging station. My battery is low, right? So there will be some kind of sensor inside my electric vehicle. Again, the GPS sensor will be there inside my electric vehicle. So those data will be stored to the cloud devices, right? Those data will be forwarded or shared to the cloud devices, and the cloud device, what it will do, it will analyze that data, it will process that data, and it will again give the notifications on my mobile phone or tablet or the dashboard of my electric vehicle, and it will tell me that battery is low and the nearing charging point is 1 kilometer away. So how do I know this nearest charging point is 1 kilometer away? How can I get this location? Can anyone tell me? Hello, am I audible?
Yes, you are
Yes, sir.
audible.
Yes,
Right.
sir.
So how can my vehicle, or how can I see inside my mobile phone that the nearest charging station is 1 kilometer away? How, with the help of which technology or which device I can see that?
Google Maps, sir, or GPS system is available.
Right. GPS system. So there will be two sensors, even in GPS sensor or global positioning system, we call that. So it will be even in my electric vehicle, even in my mobile phone, even at the charging station, and all those things will be connected with satellites, and that satellites will come connected. That satellites will be connected with an cloud devices, and they will again process that data with the super computers, and again that data will be shared over the internet to my mobile phone or tablet, and I'll get to know that what is the location, right? So
Yes, sir.
now we'll see.
Yes, sir.
Right. So now we'll see what is the charging infrastructure. Now we'll see what is the charging infrastructure and its components, right? So this is the electrical distribution services. So this is our utility distribution network of government, state electricity boards, right? So there will be this 440 volt of lines will be connected with the utility pad mounted transformers, and these transformers will provide the supply to the meters, so that those meters will be able to read and calculate whatsoever the what are ratings, or whatsoever the unit will be consumed by the panel or the EV charger or electric vehicle. Again, the panel, there will be panel, so that even if there is some even there are some maintenance in the EV charger, so we can cut off the power from this panel. There will be some MCBs or circuit breakers or isolators inside that panel, so that we can cut off that supply, and we can give some maintenance to our EV charging station. Right? Those panels will be connected to the EV charger, and EV charger we can directly plug in that EV charger plug to our electric vehicle. So this is the facilitator, enabler, and the main will be the provider who is providing us the electricity, right? So this all these things will be electric distribution services. This might be government or power, whatever will be given as in the government, and this will be electrical vehicle supply equipment. This will be this is the electric vehicle supply equipments. So what is EVSE? EVSE refers to the charging equipment that safely connects an electrical vehicle to the main electrical supply, right? So we are having this electrical supply is there inside this EV charging point, EV charging station. So we can't just directly connect our utility pole supplies to our electric vehicle, right? So there is need of some safely connections to be there. Should be made some safely connections so that our electric vehicle can maintain that electrical supply to get charged, right? So EVSE also EVSE is also needed for the authentication, metering and payment services and remote monitoring, so that all the payments will be done virtually by the means of Phone Pay or Google Pay whatsoever. So this metering payment service will be done like that, or there might be some credit card like of things, so that we can just swipe our card. There will be some smart cards, right? So we can just swipe our card and our electric vehicle will get charged. What is the charging protocol? There are different types of charging protocols like AC charger and DC charger. Depending upon the vehicle, we can choose the AC charger or DC charger. We are going to see these things in detail further. Are you with me?
Yes.
Yes, sir.
Yes, sir.
Right. So charging protocols define the type of connector that goes into vehicle inlet, max power and max voltage for the connection, communication protocols and type of communication link, right? So there are different types of communication protocol. There are different types of communications link. So there will be like AC charger, DC charger. There will be battery, right? So we can see here there is a plug, right? This plug will go into the AC charger, right? And another plug will be go into our AC inlet of our electric vehicle. There are some connectors, and there will be onboard charger. Onboard charger will be connected to the BMS. BMS. Does anyone know what is the full form of BMS?
Battery management system.
Yeah, right. Exactly. BMS means battery management system, and this battery management system will be connected with the battery so that it can monitor what is the state of charge, what is the health of battery, right? And in case of DC charger, this DC charger will be directly connected to the DC inlet. There won't be any onboard charger if we are going to charge our electric vehicle with the DC supply. So how the IoT plays role here, the Internet of Things, how this thing play a role here. A cloud-based service backend system managed by the company operating the charger. The central management system, the CMS, will be the cloud-based backend system which will be operating by the charging station, the company of charging station. This EVSE will communicate with the CMS to manage the user's authorization, billing, and rate of charging, right? So what will this EVSE do? All this EVSE will communicate with the cloud base, means it will be connected with the internet, right? So that the authorization or the billing or whatever the charging rates, there will be different types of charging rate, depends on the depending on the vehicle, depending on the how much unit the charge has been drawn, or depending upon the AC charging or DC charging, right? So there will be different types of rate. So CMS means Central Management System is really important for this kind of things, like for authorization, billing, and rate of charging. The CMS will also enable the user-facing app to help end users finding the nearest charging station and reserve a charging slot and pay. Right? Yes. Any questions? Yes. Any questions from audience? Can you please turn off your mic?
No, sir. Everything you are clearly explained.
Right. So this CSMS Central Management System app will also enable the user, right? So this mobile app for the users will enable the user to see the or to find the nearest charging station. Just I have given you example of GPS, right? With the help of GPS, we will be able to find the nearest charging station or even the reserve a charging slot, right? I know that after half an hour or after 1 hour, I'm going to reach at my college, or I'm going to reach at my office, or I'm going to reach at a mall for a movie or shopping whatsoever. So I can just reserve a charging slot there, and I can go and directly charge my electric vehicle, so that I'll not need to stand in queue and wait in the waiting line to get my number and charge the electric vehicle, right? And I can also pay in advance, or there might be some options like charge now and pay later. So there will be different types of user schemes, different types of schemes for the user from the company, so for marketing purpose or whatsoever. So what are the different charging station components? So there are the main charging station component will be charging cables, right? The charging cables which we use inside the electric vehicle will be of copper wire, right? There will be copper metal which has been used, which is a good conductor of electricity and heat, right? So for for charging, we are going to mostly use the copper cables. So there might be different types of copper cables like XHHW wire cables, cable in conduit, multi-conductor CU 600 volts. So depending on the voltage ratings, depending upon the voltage ratings and the current ratings, we can see that we can finalize our whatever the copper, whatever the wire or whatever the cable we need to use, right? Again, there will be some battery storage systems. So battery storage systems are nothing but electrochemical devices that charge or collect the energy from the grid, right? So there will be some battery storage devices or battery storage system that will be connected with the grid, so that battery will store that energy from the power plant, and it will discharge that energy whenever it will be needed, just like a generator, right? So generator is not a clean energy source, but the battery is a clean energy source, right? Again, those battery storage devices can also get energy to charge from the renewable energy sources, just like solar panels or wind turbines. Or we can just directly connect our charging station with the solar panel devices or wind turbine devices. Again, there will be some switch gears, so that for controlling, measuring, signaling, and protecting our equipments, there will be some transformers there. Some low voltage switch gears will be there, like isolators or the circuit breakers, so that there will be greater safety, right? For the safety purpose also. Again, for monitoring how much voltage has been, how much voltage drop has been gained across the devices, or what current is flowing through them. So all the internal and mechanical interconnections are there, right? So there will be different types of softwares like PLC, SCADA or whatsoever be there. So this is just an overview, right? We can see here this solar, this electric charging station. This charging station we are going to connect with our electric vehicle, so that this will be connected with switch gears. We are having here photovoltaic plant, photovoltaic PV plant means solar energy system. Again, this wind turbine will be there. So this will be connected with switch gear, and this switch gear will be operate as an isolator or the measuring device or processing device. This energy will be stored inside this BESS, battery energy storage system, right? And whenever the sun will be down at the night time, or whenever the wind energy won't be available, so we can acquire that energy from this battery storage system and we can charge our electric vehicle. Am I audible to you? Hello?
Yes, sir.
Yes, yes.
Right. So types of EV chargers. Okay. So there are different types of EV chargers, as I have told you. The AC charger. Every vehicle has an onboard AC charger. But the disadvantage of electric of an AC charging is it is of limited power and there will be slow charging, right? And DC charging. DC charging will be another option. The infrastructure investment is shared among the hundreds of users. If we are giving the DC charging infrastructure, it will be used for the hundreds of users. Large power ratings will be there and there will be fast charging. Again, the capable of integration of renewable energy. So if we are using AC, then again we are going to need to, we are again going to need the onboard charging. So connect that AC, convert that AC into DC and then supply to our battery. But here the integration capabilities are easier, like renewable sources generates the DC current only, DC supply only. So we can directly provide that supply to our DC fast charging station. It will just manipulate some of those things and it will give our those that supply to our battery. So first type of charging is the trickle charge. The slowest method of charging of our electric vehicle at home, right? So it will be directly get charged at our 220 volt plug, our domestic supply, and it is just recommended in urgent cases like we are not having any kind of other charges, or if there is an emergency, then we can use this trickle charges. This is really slow method of charging. It is the slowest method of charging of our electric vehicle at home. Yeah. Then again, there will be AC charger. AC charger will have the wall box instead installed at our home or a public place, right? So it is it can charge our electric vehicle 3 to 4 times faster from the trickle charging, this trickle charging, right? So it is like a good amount of charging will be done by here. And another is DC fast charging. The DC fast charging is the fastest way to charge the electric vehicle at a public DC fast charging station with the power of 50 kilowatt with and above. So there are like DC fast charging stations of 50 kilowatts and above. With the help of these methods, we can charge our electric vehicle from 20 to 80% in the in approx of 40 minutes. Only in 40 minutes, our electric vehicle will be get charged 20 to 80%. And ultra fast charging. Again, there are another concept, ultra fast charging, and it readily provides 150 kilowatts of energy. Now, if there is if this high amount of energy is being given, so we'll need that kind of infrastructure for DC charging. It's costly, but it requires really less time to get charged. So this is our charging system layout. So what's happening here? This is our AC charging station. So AC supply has been given. There will be safety interlocks at our charging plug, and there will be charge controller which will communicate with our onboard charger. So in onboard charger is placed in electric vehicle. In onboard charger, there will be rectifier to convert AC to DC. We all know that battery is an DC supplies DC storage device. So we are going to need the DC supply to provide the battery. So this rectifier will convert AC into DC. Again, this DC converter will have some power control unit which will communicate with battery management system, and again with the protection circuit. So they will compare these things on the battery's parameter, and it will give the CCCV charging. CCCV charging is nothing but constant current and constant voltage charging. So it will decide these parameters. Battery management system will sense all the terminologies of the battery, and it will control how much charging has been done of our battery so that it remains in the safe condition. So this is AC charger. So as we can see, this is our charging plug. This is charging plug has been attached with our electric vehicle, right? So at the one there will be some input protection. At 2 will be auxiliary power supply, right? At the 3 there will be communication. Here will be screen, or at the 4 there will be user interface. The screen will be there, so that machine or that charger can interact with the user, right? 5 there will be servicing panel. This panel will be able, we can open this panel for any kind of maintenance. And 7 there will be relays and contractors, right? So there, sorry. So this is having the rate of charging. The rate of charging will be 2.5 kilowatts to 3 kilowatts, depending on the battery power, right? Whatever the capacity of the battery will be there, it will require from 1 hour to 6 hours. Again, if there is level 2 charging, there will be charging rate of 7.7 kilowatts to 22 kilowatts. It will charge our battery with the higher power rate, so that the less time will be required to get our battery charged. It is again the advantages will be its cost effective. They are easily available, and installation is simple. But the disadvantages are there. They will be slow in charging, and there will be limited power supply, since AC power supply depends on the capacity of onboard charger. Again, we'll see the DC chargers. DC power is directly given to the battery by bypassing the onboard charger, right? So in first case, there will be onboard charger present inside our electric vehicle. But in DC chargers, what happens? We are going to bypass that onboard charger, so that can you please turn off your mic? Kindly keep a note. Please turn off your mics. So your advantages will be charging speed will be high, the ability to charge the more drivers or the more electric vehicles in a day, and disadvantages are there. So they are expensive. There are complex components and large space is needed, and it needs the large power supply. Again here, at the one point there will be the power distribution unit. At the second point, here we can see in the image, there will be input protection, there will be some relays or MCBs. At 3, there will be some auxiliary supply. At 4, the rectification will be done here. Rectification will be done from AC to DC. The high frequency converters are also present there, so that even if there is some frequency disturbance, so it's rectified. Again, at 10, there will be some DC output protection. 12, there will be some charging. There will be charging plug. At 13, there will be communication device, right? This will be communication device which will be connected with an user or internet or with IoT. At 14, there will be user interface, and at 15, there will be service access panel. This is level one charger, right? So here we can see this is line 1, this is line 2 or neutral. Here control pilot is there, here proximity pilot is there, and here will be our protective earthing. Am I audible to you all?
Yes, you are audible.
Yes, yes, sir.
So the charging speed here at the level 1 charger will be 3 to 5 miles per hour, and we can locate these chargers at our homes or workplace or public places, right? So level 1 charging works with the plug-in hybrid electric vehicle PHEVs because it has smaller batteries, right? Those electric vehicles have smaller batteries.
Sir, how are you claiming that charging speed in miles per hour?
So like miles per hour means even if we charge with the AC charger, so there are the supply is very less at our household, right? We are just having like 15 to 16 amperes. We can just draw that 15 to 16 amperes or maximum 32 amperes at the rate of 230 to 240 volts. And if there is the heavy batteries, so that it will just charge our electric vehicle. If we charge, it will just travel for 3 to 5 miles, right? So that charging speed is very less as compared to level 2 chargers. So we can see here level 2 chargers, even if we charge our electric vehicle, which is having the heavy battery, right? If there is some heavy battery, if we charge it for 1 hour with the level 2 AC charger, so that our electric vehicle can run for 12 to 80 means per hour, means not just like we need to charge our electric vehicle for 1 hour, then only it will run for 12. Means if I charge my electric vehicle for whole complete 1 hour, then it will run up to 80 kilometers. It's a range. We can't specify how much the electric vehicle will travel in single charge, right? It again depends on the temperature conditions, environmental conditions, or traffic conditions. So how much power supply we are giving to our battery pack, it depends. It totally depends on that, or how much capacity is there of our battery pack. I hope you got it.
Yes, sir, I understood.
Okay. So here some line, some L1, L2, L3 is there, neutral is there. There will be protective earthing, proximity palette, and control palette. So these are the pins. Again, the level 2 charging is nowadays used mostly in electric vehicle. Nowadays we are using the level 2 chargers. So the level 2 charger charging equipments can be installed at home, at the workplace, as well as the public locations like shopping plazas, trains, or other train stations or other destinations. So this is the pin. So we can see here the DC charger, right? So this is the DC charger. DC charger. Again, the DC charger is having level 1 and level 2 of 80 kilowatts at 500 to 50 to 1000 volt and 400 kilowatts at 50 to 1000 volts, right? So it's like high power charging for commercial vehicles. There are some private vehicles also which supports the DC fast charging for electric cars and light trucks, and extension of the CSS fast charging station is standardized and underdeveloped for the large commercial vehicle. This is like this is the pinout for CHAdeMO looking at the end of electric vehicle. So these are the specifications. FG means ground, S1 and S2 means the charging charge sequence signal. NC will be not connected to anything. DCP means the charging is enabled. As this pin will be connected, charging will be enable, and vehicle will grant EVSC to connect the chargers, right? The DC power supply, right? DC positive and DC negative. Here we can see the DC positive and DC negative. The PP will be proximity connector, right? Proximity detection, so that to charge the interlock, disable the drivetrain while connected. So whenever the charge is been plugged, so we can't drive that electric vehicle. We will need to remove that charging plug, and then only we can drive our vehicle. And CH and CL will be CAN bus, CAN high and CAN low. It will communicate with the EVSC and our electric vehicle, so they can communicate with each other and establish the operational parameters. Am I clear?
Yes, yes.
So we are going to see the smart grid now, right? A smart grid is an advanced energy grid that uses the modern digital communication, and advanced electric grid, right? The monitoring technologies and optimize the generation, distribution, and consumption of electricity. It is designed to improve the efficiency, reliability, and sustainability of the power system. So it is an integration of different types of renewable energy sources or non-renewable energy sources or different types of distributed energy sources. So after we are integrating all those things, we are going to establish, or we are going to efficiently use all the power systems. Smart grids uses the sensors, meters, and other devices to collect the real-time data from the on the electrical usage and network conditions. Which is then analyzed and used to make more informed decisions about how to manage the flow of electricity, right? So all these things are connected with sensors, actuators, meters, and other devices, so that they can calculate that data, they can work on that data, and they can communicate with them. And analyze all those data, so that the workflow, or there won't be any disturbance in the supply of powers, right? So before, what the thing was that there were fewer larger power plants like thermal power plants, coal power plants, right? But nowadays, what is happening? There are many small producers, like even at the farms, the government is giving the subsidy to install the solar water pumps, or even at our homes, we are trying to implement solar water heaters or solar energy devices, right? Solar inverters. So now there are many small producers of power, right? First, how the market was there, it was mostly centralized, and now it's ignoring boundaries. It's decentralized. Means even the different countries are sharing their electrical production. How the transmission was done for before? The transmission were based on the large power lines, right? But nowadays, what's happening, including the small scale transmission and regional supply, even the battery can be used for the transmission of energy. Distribution was from top to bottom, right? Only from grid we were able to receive the supply. But nowadays, what's happening? The distribution is in both directions. If we are installing some kind of solar project, solar panels at our home, and if we are generating excess energy, so we can sell that energy to the government electricity boards, and that charges will be cutted down. Again, the consumer was passive and only paying. But nowadays, how the consumer is, it's active and it's also participating in the system. So what are the smart grid features? It's having the advanced metering infrastructure, so that there will be two-way communication between the customer and utility company, right? So there will be easy data transmission, there will be easy calculations, and this will allow the real-time monitoring of the energy consumption for both the consumers also and utility companies. So it will enable the dynamic pricing, right? So it will reduce the pricing. It will reduce this. Again, the automated demand response, ADR, right? So if there is some peak demand at the period of strength at the period of load condition, so what will happen? It will be not just sustain on the power plants. It will also demand the power from the user, right? So the user will be also able to provide that demand, right? So whenever the demand will be there won't be any blackouts, because it will adjust that electricity usage during peak demand periods. Again, the distribution automation, the smart grid technology can monitor and control the distribution for the electricity across the grids, right? The smart grid technology can monitor and control these things, allowing the QAker identification and isolation of faults. If there is some isolation of there will be some faults, or there will be some restoration for services, there will be some maintenance in case of outages. So this will be smartly monitored, and there will be quicker identification. Energy storage system. Again, this smart grid technology can integrate with energy storage systems such as batteries to store the excess energy. Whenever there will be excess energy, so that we can store that excess energy inside their batteries, and we can use that energy whenever we'll need. Whenever we are going to need that energy during the peak demands. Renewable energy integration. The smart grid can integrate the renewable energy sources such as the wind and power, right? So even we can integrate our smart grid with the help of renewable energy integration. We can add these things. We can add the wind power, solar power, so that there will be less pollution and more efficient energy source will be generated with the help of this wind and solar. So what is another concept? Vehicle to grid. Vehicle to grid, V2G, is a technology that enables the electric vehicle EV to not only draw the power from the grid, but also to return the power from the grid, right? If I am having here battery, here transmission is there. Transmission at my home, I am getting the transmission from supply from the grid, and there will be V2G, vehicle to grid. Again, the vehicle to grid will get supply from the from the grid, and the charging will be done. But what will happen when there is very demanding phase or demand in the load? So I can use this battery as a storage energy device, and I can utilize this energy, whatever the energy will be stored inside this battery. I can utilize that energy, and I can sell it again to the distributor, so that even he'll be able to use that energy. So what will be the application? There will be grid stabilization. So there won't be any blackouts, there won't be any brownouts. So with the help of this V2G, vehicle to grid, it will help us to, it will help the grid to stabilize during the high demand periods by allowing the electric vehicle to discharge power back into the grid. Again, there will be renewable energy integrations, as I have told you. The solar energy, wind energy, hydro energy will be get integrated with this vehicle to grid, so that during the peak demand loads, we can take the energy from the battery pack of the electric vehicle, and we can sell it again to the grid. Again, the peak shaving, V2G can help to reduce the peak demands on the grids by allowing electric vehicles to charge during the off-peak periods and discharging power during the peak periods, right? So what we will do, we are going to do peak shaving, means wherever there will be less demand of electricity, at that time I will charge my electric vehicle at the lower cost, and whenever there will be demand in the energy, I will sell that electrical energy at the higher cost. Energy storage devices. V2G can provide an additional source of energy storage devices of the grid for the grid, which can help to reduce the need of expensive and polluting peak plants. Again, there will be cost saving. V2G can provide the cost saving for both for EV owners and grid operators. I have told you, and I have given you an example just right now. With the help of this, we can earn money by selling the excess power to the grid, while grid operators can avoid the need to build the newer power plants or transmission lines. Right. So the audience are free to ask questions. Was I clear with all the things which were given in the PPT in the today's session? Yes, are you audible?
Yes, sir. You're audible.
Yes, sir.
Right. So I hope you all have understood whatever the content was there of today's webinar.
Yes, sir.
If any questions, you can ask.
Sir? Yes, sir. What is the price of this level 1, level 2 charger?
It depends on the location, right? It depends on the location. It depends on the brands, right?
Still average means any idea?
Like it costs up to 55,000 to 1 lakh rupees, or even like for our homes, right? And if we are trying to set up the charging station for the commercial use, right? So it will go into lakhs. Like we need to create all that infrastructure. We need to build the transformer. We need to install the transformer. We need to take all the government signature, government authorization. So it will go like it will go in the lakhs, right?
Okay.
Hello.
Thank you.
Hello,
Yes.
sir.
Yes.
How IoT is going to just do some in this charging stations, and when the charging station is under repair, how other arrangements are there?
Right. So at whenever the charging stations are at maintenance, so there might be some optional charging stations. If like if there are three charging stations at one location, so there will be two charging station will be in use and one will be in maintenance. They can simultaneously or they can consecutively maintain that charging stations, right? So
But the cost will be double, no? If charging stations are two at one
Right.
place, then cost will be double.
right. So cost will be increased, right?
Yeah.
Right. And how the IoT will for answer for your another question.
IoT, how IoT is just to have some function on these issues.
Right. So IoT can help us with the locations, right? IoT can also help us with maintenance. It will just analyze the data. It will right. It will collect the data and it will monitor. It will give the message or alert to the charging station owner that the charging station has been came to maintenance or there is some kind of fault, right? Or when the charging has been done of electric vehicle, so that charging station will connect with IoT and that IoT will connect with the user or the owner of electric vehicle that your electric vehicle has been
Fully
fully charged, right? So they will communicate with us, right?
Or whether it can be possible that this communication, if charging station is under repair, maintenance, that message should go to the user which is passing through that road that yes, it is
Right, sir. Like there will be some functionalities. If there is some charging issues inside that charging station, so it won't show that charging station at GPS, right? So it will skip that charging station from GPS, or it will show the red mark that charging station is out of the service, right? Again, I've given you another example. We can book the slots, right? Even it will just diminish that booking slots, or it will just diminish. It will just tell that whatever charging station you are trying to book is out of service or it's under maintenance. So these kinds of these things are being implemented inside that web applications or mobile applications.
right. Okay. It is inbuilt in the car itself. What arrangement? That indication.
No, sir. Nowadays, sir,
It will be available on the mobile.
no, sir. Nowadays, there are some, not particularly in India, but outside India, like Tesla has created that whole community of Tesla chargers and Tesla electric vehicles, right? But nowadays in India, it's not that standardized. So there are different types of the different manufacturers of electric vehicle and different manufacturer of chargers. But like that, trying to standardize all these things like chargers, batteries, again the plugs, again the voltage ratings, the level of charging. Right. Tata is trying to make that community. There are Tata power station, Tata charging stations, and they can collab with the Tata Tiago. They'll connect with the Tata Nexon. So it's just like a whole community.
Thank you.
So one question. So one question from my side.
Yes.
So if I take a 1 kilowatt generator in car, then I install this charger.
1 kilowatt generator. Sorry, I have.
Car.
Means how can you take 1 kilowatt of generator along with car? Means I haven't got your question.
So actually, I put this generator in backside of car. Honda is already make 1 kilowatt generator. If I take this, then I install the charger in the car. In case of emergency, I will use this.
No, means I haven't got your point properly. Like means you have installed the 1 kilowatt generator inside your electric vehicle,
Yes, sir. Yes, sir.
and you charge your electric vehicle with that generator.
Yes, sir. Yeah. And I charge my electric vehicle through AC current. There is any facility to convert it into DC or directly to AC?
So like your generator is giving you
Purpose is charging.
right. So your generator is giving you the AC supply at the output, right?
Yes, sir, absolutely. But I want to charge the car. Then you give the source. What is the?
Right. So if you need to charge the car, so
Yes,
is your car having the which kind of charging? Right. It's AC charging or DC charging. Obviously, it will be like your charger is your vehicle is having onboard charger, right?
Yes, sir.
Right. So you can just you'll need to check the proper voltage ratings, or you will need to like install some kind of communication device to your generator and to your charging point, so that there won't be any voltage fluctuations or any current fluctuations. You need to be very
If
clear,
everything is
very safe with that, right?
yes, sir, yes, sir. But everything is well, then it is possible.
Yes, it's possible. Why not? It's just like whatever energy we are getting from the power, our power station, that only supply is being getting. But you need to very
Required.
specific, right? But you need to be very specific with current and voltage, right?
Absolutely, sir.
Yes. Any other questions? Yes. Any other questions from audience? Okay. So yes.
No, sir. Sir, feedback link is not open.
Yes, it will be shared with our team. It will be shared by our team.
Sir, my question is,
Right? Yes.
sir, why in AC is a slower charging rate in stations?
AC is
And
slower.
but
Right.
why, sir? Because everything is used in AC. But
Right,
when
right.
you are converting in DC, that's why we require some components. We require some DC
Yes.
converters. That is a cost of out of range.
Yes,
That
yes,
is
yes.
any solution that you can provide us.
Yes. See, now when we charge our electric vehicle with the AC supply, so there is onboard charger which is installed inside our electric vehicle, which converts AC supply into DC supply and provides that DC supply to the electric vehicle, right? But while we are giving that AC supply to our electric vehicle, we can't give much current, or we can't charge it with higher watt rating, higher supply ratings, because it will need the more heavy wires, and if we use the heavy wires again, the weight of the car will get increased and its efficiency will get decreased, right? But in case we are using this DC charger, all the energy conversion is done outside the electric vehicle. The AC is being converted to DC, and we are just plugging that DC to our electric vehicle, so we can charge our electric vehicle at the higher power ratings, so that there will be not any safety issues.
Yes, sir. Thank you.
Okay. So with this, I would like to wind up these sessions. So you can contact us and you can just visit our website at the hhpts at the ISIEINDIA.com or www.imperialsociety.in. You can also connect us with YouTube, follow us on, add us on Facebook, follow us on, connect with us on LinkedIn, and follow us on Instagram.
Sir, my last
Thank you,
question
sir.
is,
Yes.
sir, the what is about certificate is not provided in our link, because when you have opened this link, it is not open.
Yes, sir.
What is that
There is
issue?
problem in the-
At every lecture, sir, we cannot give the certificates.
This issue is there that earlier there was a numbered certificate were available. Now this issue is there, certificate gets opened sometime, but it's a numbering and other things are not there.
There might be some technical issue. You can just connect with our other team members. I am not authorized for answering those questions because I don't have any idea about that. I am a technical person.
Yes, sir. Yes, sir. Please provide a contact with link.
Yeah, you
message.
can you can see on the slide, right? The contact number has been provided at last, and you can also visit our website for other contact details. You can also mail our office members. They'll
Yes,
give
sir.
you proper direction in these things.
Thank you, sir. Thank you.
Yes, okay.
Hello, learners. Thanks for attending the webinar. I hope this webinar helped you out to upskill your learning. So I'm excited to introduce you about ISI India innovative products and services that can transform your learning and career in the EV industry. So have a look some of the videos.
Engineers, do you also want to expand your knowledge of electric vehicles and want to secure a good job in the automotive industry? Let me help you to get there with our online and offline products. ISI India has been offering specific domain courses as per the industry demands with perks like pay after placement, no cost EMI, placement assurance, globally wide certification by Automotive Skill Development Council ASDC and National Skill Development Corporation NSDC Government of India. We have range of courses in electric vehicle, computer-aided design and engineering, including postgraduate certification and executive PG program in EV, professional master certification program, specialization programs, fundamental programs, and internship in EV, CAD, and CAE. Our postgraduate certification program in EV is specially designed for the students with 120 plus online learning hours, 100 plus hours of industrial projects and internship to give exposure of various computational tools for hybrid electric vehicle applications. It is a 12 months assured placement course with pay after placement, thus encouraging the learning without financial constraints. The course is globally valid, certified from NSDC Government of India. Our executive postgraduate program in EV is specially designed for the working professional who want to upskill themselves or looking for a career change in the EV industry. With 120 plus online learning hours, 20 plus hours of industrial projects. It is a 9-month assured placement course with globally valid certification from NSDC and ASDC Government of India. Our professional master certification program in EV, CAD and CAE is specially designed for the undergraduate students to pave their career path by providing industry relevant skills with 100 plus online learning hours, 5 plus hours of industrial projects. It is a 6-month placement assistance course with globally valid certification from NSDC Government of India. Along with the courses for skilling, reskilling and upskilling, at engineering institutes across India, we are setting up a state-of-art facility, Center of Excellence for e-mobility research and skill-based education, which is equipped with research and project-based learning-oriented experimental setups. This Center of Excellence is not only limited to educate the students, but also it will be utilized for research, innovation and product design and development. It is a combination of 6 labs including EV powertrain training and research lab, battery BMS training and research lab, EV charging and battery swapping lab, software modeling and simulation lab, innovation lab and renewable energy lab. Each lab is consists of number of customized workbenches and machineries. Few of them includes EV drivetrain experimental setup and motor testing workbench, hybrid drivetrain experimental setup with data logger, EV machine cutout section workbench, 2-wheeler, 3-wheeler, 4-wheeler training workbench, battery load capacity testing, battery BMS with CAN protocol workbench, V2G setup, on or off grid work charging station, battery swapping, autonomous vehicle training workbench, solar power generator and software solutions, and many more. No matter from which branch you study, we commit to skill and assure you a success in your career. We have spread the joy on thousands of faces, becoming their partner along with the journey towards success. Join us and take advantage to unlock endless career opportunities.
Thanks, learners, for watching this video patiently. As mentioned, we have a proven track record of success, and our clients have seen significant improvements in their learning and career. So, any of you want to enroll in the course or ready to take your career to next level, kindly send us the inquiry through a QR code displayed on your screen. Those who are interested only in knowing the courses, details of the courses, just only those who have to inquire through the QR code. Thank you, everyone.
For course inquiry, please scan this QR code. Our team will contact you.